What if the most important discovery on Mars wasn't announced on a stage, wasn't tweeted, and wasn't explained in a press conference? What if it was uploaded quietly, labeled carefully, and then buried beneath thousands of other images, charts, and data files? Every day, NASA releases raw footage from Mars. Anyone can access it. Anyone can download it. And yet, almost nobody looks closely. Because hidden inside this ocean of data are things that don't fit neatly into headlines, things that don't come with conclusions, things that raise questions science isn't ready to answer yet. This isn't a story about aliens. It's not about secret bases or ancient cities. It's about something far more unsettling. Evidence that Mars is not the dead, silent world we once believed it was. And why the most uncomfortable discoveries are often met, not with denial but with silence. Tonight, we're going to look at what NASA found on Mars, why it matters, and why almost nobody is talking about it. Mars wasn't always the frozen desert we see today. Billions of years ago, this planet had rivers, lakes, possibly even oceans. We know this because the surface of Mars is scarred with channels that look unmistakably familiar, the same kinds carved by flowing water on Earth. This matters for one reason above all others. Where there is water, there is possibility. Mars formed around the same time as Earth. It shared similar materials, similar chemistry, similar chances. If life ever emerged beyond our planet, not in some distant galaxy, but close to home, Mars would be the most likely place. That's why we didn't just send one rover. We sent many. Each mission wasn't searching for creatures or civilizations. It was searching for something far smaller, something far older. Clues. Clues that life may have once had a foothold on a neighboring world, and that we might be closer to the answer than we think. When a rover lands on Mars, it doesn't just take pictures. It becomes a moving laboratory. Every day, it scans rocks, drills into the surface, analyzes dust, measures radiation, and photographs everything around it in extreme detail. Curiosity, perseverance, opportunity. Together, they have sent back millions of images and data points. More information than any small group of scientists could ever study at once. This creates an uncomfortable reality. NASA doesn't decide what the public sees. Almost everything is released automatically. But what gets talked about? What gets explained? What gets turned into headlines? That's a different story. Scientists focus on patterns they can test, on results they can confirm, on explanations that survive peer review. Anything that doesn't fit yet is quietly archived, not hidden, just unanswered. And sometimes the most interesting discoveries aren't the ones scientists explain, but the ones they haven't figured out how to explain yet. Some of the most debated discoveries on Mars aren't lights in the sky or strange signals. They're rocks, ordinary at first glance, until you look closer. Layered formations stacked with precision. Smooth, rounded spheres scattered across the surface. Textures that resemble sediment pressed slowly over time. On Earth, these kinds of structures are often shaped by water, sometimes by microbial activity. That's why these formations immediately caught attention. NASA explained many of them as the result of erosion wind, carving stone over millions of years, chemical reactions slowly reshaping the surface, and in many cases, that explanation makes sense. But not all of them fit perfectly. Some layers are too uniform. Some spheres appear clustered in ways that are difficult to replicate in labs. Some formations seem to preserve patterns that shouldn't survive in such a harsh environment. None of this proves life ever existed on Mars, but it does suggest something important. Mars remembers its past far better than we expected, and sometimes those memories are written in stone in ways we don't yet fully understand. In 2018, NASA confirmed something that quietly changed the Mars conversation. Organic molecules were found in Martian rock. The word organic caused confusion and disappointment and skepticism because organic does not mean alive. It means carbon-based, the basic chemical building blocks used by life as we know it. These molecules were trapped inside ancient rocks, protected from radiation for billions of years. That alone was unexpected, but what truly surprised scientists was their complexity. These weren't simple traces easily explained away by contamination. They were structured, ancient, and persistent. On Earth, similar molecules are often associated with biological processes. Though they can also form through non-living chemistry, NASA's announcement was careful, measured, almost restrained. No bold headlines, no dramatic claims, because science doesn't celebrate possibilities, it waits for proof. Still, one question lingered quietly in the background. If Mars preserved organic molecules for billions of years, what else might it have preserved? Mars has a gas that shouldn't behave the way it does: methane. On Earth, methane is usually a byproduct of life microbes, breaking down organic matter deep underground. Mars, however, is different. Multiple instruments have detected methane spikes in its thin atmosphere. They appear suddenly. They fade away. Then they return, sometimes in the same locations, sometimes not. This behavior is difficult to explain. Geological processes could produce methane chemical reactions between rock and water, or ancient gas slowly leaking from below the surface. But those explanations struggle to account for how quickly the methane disappears. Sunlight should destroy it gradually, not make it vanish overnight. NASA has acknowledged the mystery, published the data, and then moved cautiously forward. Because methane doesn't point to a single answer, it points to a question. Is Mars still chemically active beneath its surface? Or is something else, something far older, still quietly at work? For now, the gas comes and goes, leaving behind uncertainty instead of conclusions. Some of the most controversial moments in Mars exploration came from a single frame, a photograph. Shadows that appear too deliberate, textures that look strangely familiar, shapes that seem intentional. Over the years, certain rover images have spread rapidly online, zoomed in, outlined, analyzed pixel by pixel. To many viewers, they resemble artifacts. To others, just rocks. This is where the human mind becomes part of the experiment. Our brains are wired to recognize patterns even when none exist. A phenomenon known as pareidolia, faces in clouds, animals in rock formations, meaning in randomness. NASA is well aware of this effect, which is why every image is examined cautiously, from multiple angles under different lighting conditions. Most of these anomalies eventually receive mundane explanations: perspective, erosion, shadows, at low sun angles. But not all images are immediately dismissed. Some are flagged, revisited, compared with future data. Because in science, curiosity is not the enemy. Certainty without evidence is. NASA rarely uses dramatic language, not because discoveries aren't exciting, but because words carry consequences. One premature claim could undermine decades of scientific trust. One exaggerated conclusion could erase years of careful work. So, when something unusual appears in the data, it isn't announced with certainty. It's described with caution, consistent with, possibly formed by, requires further study. These phrases may sound evasive to the public, but to scientists, they are shields protecting truth from speculation. This careful wording creates an unintended effect. Extraordinary findings often sound ordinary. Profound mysteries are wrapped in technical language, and the excitement fades before it ever reaches the public eye. What sounds like hesitation is often discipline. What sounds like silence is often responsibility. Because science doesn't rush toward answers. It waits until the answers can survive being questioned. While the world's attention drifts, something historic is happening on Mars. Perseverance isn't just exploring. It's collecting tiny tubes, carefully sealed, each containing a sample of Martian rock or soil. The first pieces of another world that will eventually come to Earth. It may not make headlines now. There are no alien skeletons, no dramatic signals, just tubes and patience. But for scientists, this is monumental. Some of these samples were chosen because they may preserve ancient organic molecules. Some might contain clues to Mars' climate billions of years ago. Some could finally answer the question, did life ever exist here? The remarkable part? No one knows what these samples will reveal. Not yet, and that is precisely why this moment matters. For once, Mars is not just a distant rock. It's a puzzle we can physically hold, a story written in stone, soon to be read on Earth. Here's the truth no one is shouting about. The real discovery on Mars isn't about aliens. It isn't about hidden cities. It isn't about conspiracies. The real discovery is this: Mars is far more complex than we imagined. Its surface holds secrets. Its chemistry behaves in ways we don't fully understand. Its history is written in a language we are only beginning to read. Every rock, every gas spike, every preserved molecule is a reminder. Our models of planets, life, and geology are incomplete. NASA's caution, the muted announcements, the careful words, they aren't hiding anything. They are protecting a truth that is bigger than a single headline, because sometimes the most important discovery isn't a single moment. It's a quiet accumulation of questions that force us to think differently about the universe. Mars is alive, not in the sense of walking, breathing life, but alive in memory, in chemistry, in possibility. So why isn't anyone talking about these discoveries? It's not a conspiracy. It's not censorship. It's the nature of science itself. Science moves slowly. It thrives on patience, not headlines. It waits for certainty before making bold claims. Public attention, on the other hand, favors drama, certainty, conclusions. A methane spike that disappears overnight doesn't make a trending story. A tiny organic molecule preserved in a rock doesn't go viral. Questions don't get clicks. But questions are exactly what Mars provides. Every anomalous rock, every shadow, every spike in methane or a hint of chemistry. Silence doesn't mean absence. It means the work is ongoing. The answers are coming, just not on a schedule dictated by social media or news cycles. Mars is quietly teaching us a lesson. The most important discoveries aren't announced. They are uncovered slowly, meticulously, waiting for us to understand them fully. But now you might be asking yourself, if the discoveries are so important, why aren't we hearing about them everywhere? The answer is simple. Mars doesn't shout. It whispers. It leaves clues, puzzles, and questions in its dust and rocks. It challenges our understanding in ways that headlines can't capture. The most profound discoveries often arrive quietly, hidden in data, tucked into a tube, preserved in a rock billions of years old. They demand patience, careful thought, and curiosity. What we're seeing on Mars is remarkable. A world that remembers. A world that holds its history in silence. A world that asks humanity to look closer, think deeper, and wait. And maybe that's the real lesson. That discovery is not about instant answers. It's about learning to embrace uncertainty, to appreciate the questions themselves, to realize that silence does not mean absence, because one day those answers will arrive, and when they do, they will change everything we thought we knew about life and our place in the universe. Until then, the mystery continues, and that is more incredible than any headline could ever convey.